Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve. Today we are going to do part 9 from chapter 13, magnetic effects of electric current.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
So the question says, two coils A and B are placed close to each other. If the current in the coil A is changed, will some current be induced in the coil B? Give reason. So this is what they are asking is that in the diagram, they are showing that this is coil A and this is coil B. Now they are showing that coil A is connected with a battery as well as a small switch. Now the switch which you are seeing it over here, children, so it is lifted up. That means just now it is incomplete. That means no flow of current is there. In coil B, it is connected with a galvanometer, and you know the meaning of galvanometer, it detects the current. Now the question says two coils A and B are placed close to each other and they are very close to each other. Now what I will do, that I will show over here that I will press this switch. When I press this switch, I mean that it is a complete circuit. And the complete circuit means that I've switched on the circuit, and by doing this, I am seeing that the flow of current started. Am I clear, children? So now I have completed the circuit, switch on, I have pressed the switch, current started. Okay. Now when I saw that the current started when I pressed the switch, and I have seen that the current started from 0 to 1 ampere, 1 to 2 ampere, 2 to 3 ampere, 3 to 4 ampere and 4 to 5 ampere. But what is this? It is not going beyond 5 ampere. But why? What is the reason? Very simple, children. That means my battery is very small because it was a small battery and it can produce only this much of current, this much of amperes of current. Am I clear? This is very important point. And hence only this 5 ampere current will keep on flowing. Now, after when the current was flowing in coil A, that means as the current started flowing in coil A, it came in my mind by the flow of current, this coil A became electromagnet. Wonderful. When the coil became electromagnet, that means magnetic field is also produced. Very simple. Because I told you over here, and you know it also, I've told you earlier also that magnetic field is directly proportional to I, that is current. Current started flowing in the circuit, magnetic field produced. When the current is flowing, that means this coil has become electromagnet. Am I clear? Okay. Now children, as this coil was having the current, now the deflection in the galvanometer I have seen also. So this galvanometer showed some deflection in the needle also. Okay, but why? What is the reason? Now, as I just now told you that magnetic field is directly proportional to current. Now, if current magnitude increases, children, please be careful. Listen to me very, very carefully. If current magnitude increases, magnetic field will also increase. Very important, children. If it decreases, so magnetic field will also decrease. Very simple. So now over here, coil A I've seen with the flow of the current, it has become electromagnet. So because of the flow of current, what is happening? Therefore, coil will now have magnetic field. Of course, I know this very well. Now it's very simple. I know this concept from the beginning. Now, children, this magnetic field which is produced over here and the coil A has become electromagnet, that is coil A will join with coil B. That means the magnetic field of coil A will join with coil B. Because of this, all reasons which I've told you just now, deflection in the galvanometer I can see, but only momentary. Please quote my word, only momentary. That means only for some time, some period only. But why? Why this short period? But for some time only I'm able to see the deflection in the galvanometer. But why? So that means after this momentary, if I see the deflection in the galvanometer, after that I see that this deflection of the needle, now I will see as a straight line over here. That means there is no flow of current. There is no induced current in coil B. But why? And this is the reason I have told you also. So that means if I'm not able to see the deflection in the galvanometer, the point straight I'm seeing in the galvanometers, there is a 0 point. Clear, children? Now, children, if I see that this circuit which was complete, I have made this circuit incomplete. Incomplete means I have pulled up the switch like this again as I'm showing you on the screen. I pulled up the switch, so it means incomplete. Incomplete means there is no flow of current. And if there is no flow of current, I cannot see the deflection in the galvanometer. But with this also, I'm seeing a change in it. How? Now, in the beginning, when the complete circuit was there, so the current started flowing from 0 to 1, 1 to 2, 2 to 3, 2 to 3 to 4, and 4 to 5. But when I made this circuit incomplete, again there was a change. But what change? But in the reverse direction, children. But there is still a change, but in the reverse direction. First, the current was increasing till 5 amperes. When the circuit was incomplete, it started flowing from 5 ampere to 4, 4 to 3, 3 to 2, 2 to 1, and then 0 and stopped. Am I clear, children? So that means the current is becoming less and lesser. Yes, children, when the circuit was incomplete. And that is why it was showing deflection when the circuit was incomplete, momentary, and then immediately afterwards it became straight. That means 0 showing in the galvanometer deflection. Am I clear, children? So this is the reason behind it, that how the coil B gets affected, or how the magnetic field is produced, or the current is induced in coil B from coil A. So for this small question, a lot of big explanation was given by me, which is really very important, and the concept needs to be clear to write the answers very well in your exams. So now, how do you write the answer? So the answer comes on the screen like this. When we switch on current in coil A, it becomes an electromagnet, which I told you, and produces a magnetic field around coil B. Okay, so an induced current flows in coil B for a moment, which I told you momentary movement. Yes, momentary. The current was shown with the deflection in the galvanometer. When the current in coil A becomes steady, its magnetic field also becomes steady. Steady means when the circuit was incomplete and the current in the coil B stops. When we switch off the current in coil A, then the magnetic field in coil B stops quickly. And in this case, an induced current flows in coil B in the opposite direction. Are you getting my point, children? So that means when the current was flowing from 0 to 1, 2, 3, 4, 5, and the circuit was incomplete, again it showed a change, but in the reverse direction, 5, 4, 3, 2, 1, 0. And this is absolutely complete answer for this question. So please always solve the question with the concepts you have done it. The whole chapter should be on your tips. And now squeeze the concepts according to the demand in the question and take out the concepts, write down in the paper in your exams to grab full marks. And please go step by step with the concepts in your hands, children. Okay, and if you know the concept, you can write it in your own words, but the key points of the answer should be there because the key points are very important for the step marking, children, which will make you, grab full marks in your exams. Okay, right, children. So now I wind up the session. So God bless you. Take care and keep on revising. Bye bye.